The Pythagoras theorem is a relationship of the three square areas from the side length of a right triangle. And again, this only works if your triangle is a right triangle. So I'm just going to highlight the right triangle in here. There's our right triangle. It's got a hypotenuse of 7. One side has an area of 25 centimeters squared, and we don't know the area of the other side. So the area relationship between the three parts. So we know that this square area here, and it's again not to do with the side lengths, but to do with the areas. This square area here plus this square area here is going to add up to the biggest square area of the hypotenuse. So if I want to find parts of the side length of the areas, I can just kind of work this out. I have a side length of 7 of the hypotenuse, so I can find area by squaring. And here I can now use the relationship. Here, although I don't know the side length or the area, I know that these two areas relate to this area in here. So a squared plus b squared equals c squared. So if I take away 25 centimeters squares from the 49, I end up with 24 centimeters squared. And from the 24 centimeters squared, I can find the side length of square root 24. And again, if I want to know approximately how long that is, I can just take the square root of that. So I can go 24 square root. It gives me about approximately 4.89. So I'm just going to round that to 4.90. Okay, centimeters of length. So these two areas are very similar, although the drawing doesn't show it, but the side length and areas reflect that. So how do we use the Pythagoras theorem? We often use the Pythagoras theorem to solve for the side length, but we need to again make sure that we're clear that we're using area. So I'm going to take this 100 squares here, and I'm going to square 24, and that's going to give me 576 squares, and the c square must be the sum of those two, so I get 676 squares here. So to find out the side length of that side c, what I can do is take 676 squares and square root it. Okay, so I end up with this c is equal to the square root of 676, which is equal to 26, whatever the units are there. I can do the same thing here. In this case, a squared plus b squared equals c squared. Here I'm going to do c squared minus a squared equals b squared. So I'm just going to write out the formula here. X squared is equal to 5 squared minus 3 squared. Okay, so I end up with x squared is equal to 25 minus 9. X squared equals 16. And I get x is equal to square root 16, which is 4. So this length works out to be 4. Now these happen to be what we call a Pythagorean triple, so we end up with whole number side length. But most triangles don't have 3 lengths that are whole numbers. So let's do this one here. So this is going to be c squared is equal to a squared plus b squared. It doesn't matter which one's a and b. So I'm going to find out the area of 6 squared plus 7 squared is 49 squared. So when I add up those two squares, I end up with a total of 85 squares for the c squared. So if I want to find out the length of c, I square root, and approximately going to be about 9.219, so I'm going to round that to 22. So c is equal to approximately 9.22. And that looks about right. If this is 6 and this is 7, that's going to be about 9. For D, we want to find the shorter side, so we need to subtract. So I'm going to take my big square, 9 squared, and I'm going to subtract my smaller square to get the small square. So I end up with 81 squares minus 49 squares equals a squared. So the number of squares that make up a is going to be 32 squares. Okay, so 81 minus 49 is 32, and then if I want to find out the length of a, so there's 32 squares in here, so if I want to find out the length of side a, I square root. So again, area to side length is square rooting, and that is approximately equal to 5.656, so I'm going to round that to 66.